Okay, so yesterday we are having such things over here, like which is based on um, this metals and non-metals. So sonorosity, ductile, malleable, high melting point, boiling point, tensile strength. Okay, the lustrous, these type of properties we learn on yesterday's basis. Okay, now talking about towards now the next thing, which is known as the melting point and the boiling points over here. Okay, now what do you mean by the melting point and the boiling point over here, which that we'll see over here? See, metals have generally a very high melting point. Okay, so the exceptions are basically the sodium and the potassium over here, which have very low melting points over here. Now as you can see, generally metals are very hard in nature. Okay, so all the metals generally are solid in nature, but the exception is there for what? For the mercury, because mercury is having what? Liquid at the room temperature. But that is the on the basis of solidity over here. Now here we are talking in terms of the metals and non-metals. Okay, so basically in metals and non-metals, what we are having a very high, especially in case of a metals only, we are having a very high melting point. Okay, if we are having a very high melting and boiling point, okay, that means we are having a metal to metal bond, okay, which is very strong with respect to each other. Okay, that's why we have a very high melting point. Okay, now only there are some exceptions, which is known as the sodium and the potassium. Sodium and potassium are very, they have very low melting and boiling points over here. Okay, they can easily melt down, okay, on the surface of the earth. They are very active towards the fire also. Okay, so if we talk about the fires and these things, then yeah, they are very aggressive, or you can say they catch very fire very easily. Okay, when it comes within contact with the air. Just a minute. Okay, hello, yeah, okay guys, yeah. So sorry for the disturbance. Yeah guys, so melting point and boiling points, I think. Yeah, so metals have generally a very high melting points. Okay, this is just because of a bond to bond interaction within the metal to metal. Okay, Coming to the next point, which is known as the specific gravity. Okay, so now what do you mean by the specific gravity over here? So most of the metals have very high specific gravities. So for example, iron is having 7.8, copper is having 8.7, and lead is basically 11.3. Okay, so specific gravity actually means what? Specific gravity means, for example, if you if you release the metal inside the water, okay, if you release the metal inside the water, so it will drown, and it will basically have it will drown inside the water. Okay, that means it has a very high density also, and it has a very high specific gravity also. Okay, but again here also the sodium and potassium is having low specific densities, which is very less than 1 over here. Okay, so that is some of the specific gravity kind of a thing which you can see over here. Okay, now these are the left topic which we haven't covered yesterday. Okay, but today, now first of all we will see the reaction of a metal and a non-metals with the oxygen first of all. Okay, so first of all you can see what we are having the reaction. Okay, most of the metals react with the oxygen to form the basic oxide over here. So first of all we will see that how metals are combining with the oxygens. So this is the metals plus oxygen. Okay, so we are having the metal plus oxygen over here. What is the reaction? For example, I am combining sodium and oxygen over here. So when you are combining sodium plus oxygen, so you are getting Na2O, that is sodium oxide. In examination you have to write like this: sodium, and this is oxygen, and this is sodium oxide. So most of the metal will form what? Metal oxide. Most of the metal will form what? Metal oxide over here. Okay, so this is what, in this case the metal is Na, oxide is O, so that is metal oxide. So you can see metal oxide is like this. Okay, this is one of the thing which you can see over here. The second example, this is the first example. Second example is what? Copper plus oxygen. So what you are getting in the form of copper plus oxygen? Again you are getting copper oxide over here, CuO. Getting the point? This is known as what? Copper oxide. This is copper, and again this is oxygen. You also have to write in the same format in the exam also. Okay, sorry guys, are you getting? This is the chemical symbol, this is the chemical name, and this is the byproduct of this reaction. This is the RHS part of the reaction, this is the LHS part of the reaction. Okay, okay, getting the point? So these are some of the things, okay, which you are getting over here. Everyone getting my point? Yes, no, maybe? This is some of the things which you can see over here. I hope you're getting the point. Just a minute. Okay, okay, so this is metal and oxygen over here, and one more thing is over here. Guys, I think you got the link on mathematics channel or on the science channel.
So Max,
On the maths channel you got the link. Okay, that's why Philip didn't join the class. And as of now, how many students are there? Sanjana, Apurva, Navdha is here. Okay, okay. Hello, yeah, hi Philip. Hello. Okay, Philip is over here. Okay, fine. So this is the reaction with the oxygen first of all. Okay, so just now what we can see when metal combine with the oxygen, so it is forming a metal oxide. Okay, so now this is the kind of a thing which you can see. Okay, but apart from that thing, there is one another thing also. Okay, which is acidic oxide. What do you mean by the acidic oxide? Now there are two type of oxide. The one thing is the basic oxide, the other one is the acidic oxide. Acidic oxide means some of the metals possessing the nature of producing the acidic oxide. Okay, if we talk about the oxide also, so oxide is also now two types of a nature. The one oxide is basically the acidic oxide, the next is basically the basic oxide over here. Okay, acidic is for those particular substances, okay, which are having a very high acidic character with respect to water also. So for example, if I'm giving one example for the acidic oxide and other example for the basic oxide also. Okay, so first of all I'm having this one thing. Okay, so what is this one thing? That is sulfur plus oxygen. So I'm having a sulfur plus oxygen and it gives us sulfur dioxide, means SO2. So this is the acidic oxide. This is the acidic oxide which we are obtaining over here. But if I talk about the basic oxide, so basic oxide is for what? For the magnesium over here, and magnesium oxide is what? That is Mg plus O2 and it gives us MgO. It gives us MgO. So this is the basic oxide. This is the basic oxide in nature. Okay, that means when you touch with your hands, so you get a itching in your hands and your skin when you have these type of acidic oxides. Okay, some of the acidic oxide reactions are already written in your book. Okay, so that is one of the thing over here. Okay, now proceeding toward the next thing, in general non-metal react with oxygen to give the acidic oxides over here. Okay, in general, non-metal reacts with what? Non-metal reacts with acidic oxide. Okay, so that is one of the thing which you can see over here. But proceeding ahead, now you are having some more. Now we are having a next thing which is reaction with water. Okay, now reaction with oxygen we have saw over here, which is now, which is reaction with water. Guys, everyone is here or not? I'm not getting any voice, I mean voice from anyone's side.
Yes, sir.
Okay,
Yes,
and
sir.
Philip, just please see the lectures, I mean please watch the lectures on the YouTube channel. Okay, for whatever the lectures that you have missed over here. Okay,
Yes, sir.
and what about the mock test? First of all, tell me, you have I mean did your mock test for all, or still some of the mock test is pending?
Sir, that it's pending.
It is pending. Okay, how many mock tests you haven't attended yet?
Wait, sir. Sir, for crop production.
Mm-hmm.
Yes, sir. For crop production, I think.
For crop production. Okay.
Yes, sir.
Mm-hmm.
Sir, and light also.
Okay. Okay, so Philip, just please send me the mock test timetable. Okay, so that I can dispatch the paper accordingly. As of now, I think your examination is going on. and just for that you haven't attended any of the test, or some of the test is left from your side, so just please look into that all the things accordingly. Okay.
Sir, my examinations are over.
That's what I'm telling. If examinations are over, so whatever the mock test that you are left in my class now that you have to attend.
Yes, sir.
Okay, yeah, fine. And now please be regular in our I mean Saturday Sunday classes.
Yes, sir.
Okay, fine, yeah. So moving ahead now, what we are having, just please have a look into it. So sodium, potassium, uh, calcium, yeah. So now we are having a reaction with water. Okay, so sodium and magnesium react with water to release the hydrogen over here. Okay, so first of all, what we are having a sodium plus water. Sodium plus water gives us NaOH plus hydrogen gas is liberated over here. Similarly, magnesium also react with water and it will release MgO, magnesium oxide, and it will again release hydrogen from this place. Okay, so like this you are having such things over here. Okay, every kind of a metal release hydrogen in the presence of water over here. Okay, similarly zinc and aluminum also react with hydrogen. Okay, and it will release it will react with water and it will release hydrogen over here. Now metal react with water. Metal plus water will shows the output, but non-metal plus water gives us no reaction, guys. Okay, it will provide no reaction. They do not show any reaction with water. Non-metals, so non-metal do not react with water, so they are very non-reactive with respect to the non-metals over here. Now generally, coming to the next thing, that is reaction with what? Reaction with acids. Now what do you mean by the reaction with acids? First of all, you have to see that there are different type of acid which you can see over here. First of all, we are having a two type of acids. The one is the HCl, that is known as the hydrochloric acid. The next thing is basically H2SO4, which is known as the sulfuric acid. The next thing is what? Sulfuric acid. Okay, so the first reaction that is carried out over here is basically sodium and HCl. Sodium and HCl gives us NaCl. NaCl and hydrogen gas is liberated over here. That means acid reaction of a metal plus acid gives us a byproduct and release of a hydrogen gas. There is a release of a hydrogen gas over here. Okay, this is one of the thing which you can see. Proceeding forward, this is reaction with what? Reaction with acid. Similarly, you can see the next reaction, which is of magnesium. Magnesium plus H2SO4, which is sulfuric acid, gives us what? MgSO4, and it will also release hydrogen. Okay, so this is also one of the next thing, but this time HCl is there, and now the next time we are having a concentrated H2SO4 over here. Okay, this is one of the thing which you can see over here. Okay, now generally we add some acid in pickles and curd. Okay, so this is just a general criteria, that a one liner question also, that first of all what we are having now, usually we are making pickles in our home. Okay, and we are storing the curd in our home. ठीक है, घर में हम क्या करते हैं ना, अचार वगैरह और ये सारी चीज़ें बनाते हैं. ठीक है, एग्ज़ाम में हमको जनरली जो क्वेश्चन आता है वो इस तरह से आता है कि जो हमारा अचार होता है या जो कर्ड होता है, ठीक है ना, उसको मेटल्स के जो बर्तन होते हैं, जो यूटेंसिल्स होते हैं, उसमें क्यों नहीं स्टोर करना चाहिए. सो द रीज़न इज़ कि उसको इसलिए स्टोर नहीं करना चाहिए बिकॉज उसमें, ठीक है, जो हमारे पास हाइड्रोजन गैस है वो रिलीज़ होती है, ठीक है. और इसी के कारण जो हमारा मेटल है जब वो एसिड के साथ रिएक्ट करता है तो ड्रास्टिक चेंजेस देखने के लिए मिलते हैं. दैट इज़ वाई हम हमेशा जो भी हमारे पिकल्स होते हैं वो चीनी मिट्टी या जो ग्लास का बर्तन होता है या जो हमारे पॉट्स होते हैं हम उसमें उसको स्टोर करते हैं. तो ग्लास जो होता है एंड दैट जो चीनी मिट्टी होती है दैट इज़ नथिंग बट अ सिलिका ओनली, दैट इज़ अ सिलिका बेस कंटेंट ओवर हियर. ओके. एंड द नेक्स्ट थिंग इज नॉन मेटल्स डू नॉट रिएक्ट विद डाइल्यूट एसिड्स. ठीक है, तो मेटल के साथ तो हो गया. अब जो हमारे पास में नॉन मेटल्स हैं, ठीक है ना, ये जो नॉन मेटल्स है ये हमारे पास में एसिड्स के साथ में, एसिड्स के साथ में नो रिएक्शन शो करेंगे. ठीक है ना, ये कोई रिएक्शन शो नहीं करते नॉन मेटल्स के साथ में, विच इज़ अगेन वन ऑफ द नेक्स्ट थिंग ओवर हियर. ओके. रिएक्शन विद बेसिस. ठीक है, बेसिस के बारे में बात करते हैं. सी नाउ एसिड के बारे में हमने बात कर ली. नाउ डायरेक्टली कम टू द बेसिस over here. Now what exactly bases are doing? Only some of the metals such as aluminium, zinc, lead react with strong bases. Some as such as sodium hydroxide, and they release the hydrogen gas. The reaction with non-metals of a sodium, okay, is very complex over here. So they were telling that in general non-metals with the acid do not show any reaction, but on the other hand if you see the non-metals, they do not react with the sodium hydroxide and they do not react with the metals over here. Just a minute. Okay, yeah, proceeding ahead now guys. Okay, so now what else we are having? Reaction with metals, reaction with non-metals. Okay, now we are having one more thing over here which is known as a double displacement reaction. So before reading the double displacement reaction, first of all we have to see the reactivity series. Okay, so reactivity series is basically what? Guys, everyone, Navdha, Sanjana, Apurva, Philip, have you read this chapter or this is the very first time when you are reading all such things with me only?
So I have read this chapter.
Okay, what about rest
Sir,
three
I
of you?
also read this chapter.
You read or not read, Sanjana?
I read, sir.
Okay, you read it. Okay, Philip, Apurva.
Sir, I've listened the teacher's explanation.
Okay, and Apurva, this chapter is omitted.
Yes, sir.
Okay. Okay, guys. Yeah. Now listen to me, guys. Okay, see, as of now, you are having what? You are having a reactivity series over here. Reactivity series is nothing but what? For example, this is a person, okay, which weighs 100 kg, and there is another wrestler or another person which is only 40 kg. Okay, now in terms of their weight, if there is a wrestling match between a person 1 and a person 2, okay, so what you can say, who will win? Who will win the match? The person who is weighing high. Are you getting my point? In general we are saying, okay, because there are so many external parameters also which is acting over here, but in general, in terms of weight only, the probability and the chances for winning the match is for which person, the person number 1 or a person number 2?
Sir, person number 1.
Person number 1. So we can say the person number 1 here is more powerful as compared to the person number 2, and which is the only reason that why the person 1 wins the match over here every time, isn't it? Similarly, in terms of metals also, there are a powerful metal and a less powerful metal, okay, and this we can explain with the help of the reactivity series. Okay, now what is the reactivity series? We can see there is a potassium, then there is a sodium, potassium, sodium, then you have the barium, calcium, magnesium, like this, and from top to bottom the reactivity decreases. Top to bottom the reactivity is decreases. That is, most reactive material is at the top. Most reactive material is at the top, and least reactive material is at the bottom over here. Okay, and this is a decreasing order of reactivity, getting the point? So if I'm having any reaction in which sodium and calcium will participate, so sodium will replace the calcium. Okay, for example, if there is a reaction of NaX plus Ca plus you are having a CaY, okay, or you are having just simply like this NaO, let us say this is a sodium is forming an oxide over here, and this is a Ca and Y over here. So what you can see the sodium get connected with a Y over here, and Ca will connect with a O over here. So initially on the reactant side, calcium is with Y, sodium is with O, but on the right hand side you can see sodium is with Y and calcium is with O. So can I say Na is a Na take the places of the C over here, or Na replace the C from its mean position? This is just because of what? Because Na is at the top, Ca is at the bottom. Okay, so this reaction is possible over here. But on the other side, for example, if I'm writing like this CaO plus NaY, then CaY plus NaO, this reaction is not at all possible, because according to the strength and according to the reactivity series, Ca cannot take the place of Na over here, so it cannot replace or it cannot break the bond. It cannot break the bond interaction. It cannot break the bond interaction between sodium and a metal Y over here. Guys, are you getting what I am saying? Okay,
Yes,
so
sir.
one of the metal replaced by the other metal on the basis of the reactivity series only, and this is known as a displacement reaction or a double displacement reaction over here. Okay, some of the double displacement and displacement reaction I will tell you. For example, I am adding iron into copper sulfate solution, so we can see we are having FeSO4 plus copper over here. So you can see iron will take the place of copper over here, and it will attached with a SO4 over here, and copper get displaced from its position. So this is because of what? We can say copper is at the somewhere top, and iron is somewhere at the top and copper is somewhere at the bottom. Then only this reaction is possible. But for example, if I reverse this reaction, okay, in terms of CuSO4, if I have a FeSO4, if I have a copper plus FeSO4, then this reaction is not at all possible, because copper do not have enough strength to displace the iron from the SO4, and that's why this is the only point. Okay, this is, I mean, this is what you are having over here. Okay, getting the point over here? Yes, no, maybe?
Yes, sir.
Just one. Yes, so now this is the what we can say, the reactivity series which we are having. Okay, so there are copper sulfate solution, zinc sulfate solution, and different type of a material, I mean metals are given, and based on the decreasing order of a reactivity series, you have to see that what are the, I mean, different type of a reaction which is occurring over here. So as of now, reaction with metal, the reaction of a metal and non-metal with water, with acid, with bases. Okay, we can see, I mean, so far we have learned about these things. Okay, coming to the next section, which is use of some of the metals. Now this is some of the things which you can read it by your own. Like आपको यूजेस पढ़ना है कि आयरन के यूज़ क्या होते हैं, कॉपर के यूज़ क्या होते हैं, जिंक के यूज़ क्या होते हैं, है ना. सो जस्ट प्लीज़ हैव अ लुक एट इट वंस. ओके, बिकॉज नाउ जो कॉम्प्लेक्स पार्ट है या जो समझने वाला पार्ट है वो मैंने आपको यहाँ पे एक्सप्लेन करा हुआ है. ठीक है, कुछ कुछ चीज़ें ऐसी हैं, ठीक है ना, जो आप खुद अपने आप से भी यहाँ पर पढ़ सकते हो. ठीक है, सो दैट आई विल नॉट एक्सप्लेन ओवर हियर बिकॉज दैट इज़ जस्ट अ रीडिंग पार्ट ओवर हियर. लेकिन फिर भी अगर पढ़ के आपको समझ नहीं आ रहा है कि सर व्हाट इज़ यूज़ ऑफ कार्बन, फॉस्फोरस, सल्फर, वेयर इट इज़ यूज, आई मीन वेयर वी कैन पुट इट. Okay, so just please mark the doubt over there and ask to me, because based on this one liner question, 1 to 4 marker question, I will dispatch the paper to you. Okay, now moreover, as of now we can see this single, which is known as the displacement reaction over here, but apart from that thing, there is a double displacement reaction is also over here. Now what do you mean by the double displacement reaction? In the double displacement reaction, you are having, for example, a metal X with A and metal Y with B. So X is connected to a B and Y is connected towards A. So you can say X takes the place of Y over here. Similarly, this B takes the place of X over here, and in this way you can see there is a displacement in the double format. X is also getting displaced, Y is also getting displaced. Okay, so X is connected towards B and Y is connected towards A. So these are some of the things which you can see over here. This is known as a double displacement reaction, and before this we have seen a single or only a displacement reaction over here. Okay, now proceeding ahead, what we are having, the uses of sulfur, uses of iron, uses of other metals also. Okay, so that is already written in your book now, but apart from that thing, now non-metals, the noble metals. Okay, can anyone read the topic about the noble metals? सी नोबल मेटल्स आर नथिंग बट वॉट, दे आर वेरी अनरिएक्टिव इन नेचर. ठीक है, जैसे कि सोडियम जनरली कैचेस अ फायर व्हेन इट कम्स with contact with the air. Okay, similarly the potassium is also exhibiting the same property only. Okay, but in case of silver, in case of gold and platinum, na, they do not react with any of the thing over there. So that's why it is saying it can be said that silver and gold are present at the bottom of the reactivity series, and they are very unreactive. Unreactive metals, they do not react with water or acid or alkali or bases. Okay, that's why they are known as the noble metals. Noble metals मतलब उन्हें कोई फ़र्क नहीं पड़ता, उनको एसिड में डालो, बेस में डालो, वाटर में डालो, किसी में भी डालो, ठीक है, वो कोई बिहेवियर ही नहीं शो करते अपना. दैट्स वाई दे आर नोन एज अ नोबल मेटल ओवर देयर. ठीक है, एंड दैट इज़ दी ओनली रीज़न कि जो ज्वेलरीज होती हैं, ठीक है ना, वो रिएक्शन ना करे हमारी उंगली पे, या फिर जो हमारे पास में ऑर्नामेंट्स होते हैं, ठीक है ना, वो कोई रिएक्शन ना करें. इसलिए हम जनरली गोल्ड, सिल्वर और प्लेटिनम यूज़ करते हैं. ठीक है ना, देयर आर सो मैनी रीजन्स. ठीक है, जैसे फॉर एग्जांपल डायमंड, सिल्वर, गोल्ड, प्लेटिनम, दे आर वेरी रेयर इन द अर्थ. ठीक है, सो दैट्स वाई देयर वैल्यू इज़ ऑल्सो हाई. अगर उसकी वैल्यू हाई है, सो दैट्स वाई इट इज़ ऑल्सो वेरी वैल्यूएबल ऑल्सो. ठीक है, आसानी से मिलते नहीं हैं वो. ठीक है, दैट इज़ द ओनली रीज़न कि हम उन्हें इन द फॉर्म ऑफ ज्वेलरी पहनते हैं. ठीक है, इसी तरह से जो मोती होते हैं, जिसको पर्ल्स बोला जाता है, ठीक है, जो प्योर पर्ल होता है, दैट इज़ ऑल्सो कॉस्टिंग अ लॉट. ठीक है, और वो हमारे पास में ज्वेलरी के फॉर्म में आता है. ठीक है, so that is also one of the thing ki why we are having such noble metals in the form of jewelry over here. But on the second hand, the reason is for the reactivity and the reactivity series also. Okay, so you have to write the reason ki although they are the metals, but they are very least reactive in the nature. That's why that's why we are wearing them. Okay, now coming toward the corrosion. कोरोजन का क्या मतलब होता है? जैसे कि द बेस्ट एग्जाम्पल ऑफ द कोरोजन इन द डे टू डे लाइफ इज़ द रस्टिंग ऑफ आयरन. जैसे हिंदी में बोलते हैं लोहे में जंग लगना, है ना. नाउ रस्टिंग ऑफ आयरन मीन्स व्हाट? देखो, आयरन को प्रॉब्लम होती है मॉइस्चर से. आयरन डू नॉट रिएक्ट विथ वाटर, आयरन डू नॉट रिएक्ट विथ ऑक्सीजन, बट आयरन रिएक्ट विथ मॉइस्चर. और मॉइस्चर का मतलब होता है वाटर प्लस ऑक्सीजन. सो इसका मतलब अगर आपने एक आयरन का पीस लिया, ठीक है, what I am saying कि if you are taking the iron piece over here, okay, for example this is the iron bar over here, this is the iron bar over here, okay, and this iron bar came in contact with water, this iron bar came in contact with water, so it will show no reaction. Similarly, if this iron bar, if this same iron bar came in contact with oxygen, then also this will show no reaction. Okay, but once this iron bar is acting with H2 plus O2, then it will show rust over here. ठीक है, इसमें जंग लगना चालू हो जाती है. ठीक है, दिस इज़ नोन एज अ रस्टिंग ऑफ एन आयरन. ठीक है, सो आयरन में रस्ट लग रही है, मतलब इसमें क्या हो रहा है? कोरोजन हो रहा है. इसका मतलब आयरन ऑक्साइड का फॉर्मेशन हो रहा है. what we are having the formation of a iron oxide over here. Getting the point? This is what? Iron oxide. So just to prevent the metal from the corrosion, or just to prevent the metal from forming the oxide, हम क्या करते हैं कि इसके ऊपर जो लीस्ट रिएक्टिव मेटल होता है उसको चढ़ा देते हैं. ठीक है, एंड दैट इज़ ऑल्सो नोन एज द कवरिंग ऑफ अ मेटल विथ द लीस्ट रिएक्टिव मेटल, और ऑल्सो नोन एज द गैल्वेनाइजिंग. ठीक है, सो ये जो गैल्वेनाइजिंग है, इसी को, ठीक है, हम एक्स्ट्रा प्रोटेक्शन या लेयर के साथ में हम यहाँ पे अप्लाई करते हैं. ठीक है, सो फॉर एग्जांपल आपने देखा होगा, जैसे कि फॉर एग्जांपल गैल्वेनाइजिंग आयरन या जीआई पाइप बोलते हैं. व्हाट एग्जैक्टली इज़ दैट? आयरन हमारे पास में है अंदर, और इसके हमने ऊपर कवरिंग कर दी एक ऐसे मेटल की जो आयरन से भी लीस्ट रिएक्टिव है, दैट इज़ नोन एज जिंक. तो जिंक क्या करेगा? अब जिंक को ऑक्सीजन और वाटर से कोई फ़र्क नहीं पड़ता. ठीक है, तो ये उसको रिएक्ट ही नहीं होने देगा. और अंदर कौन बैठा हुआ है एक्चुअली? आयरन. आयरन को फ़र्क पड़ता है, लेकिन बाहर जो जिंक की कोटिंग करी है उसे कोई फ़र्क नहीं पड़ता. सो दैट्स वाई हम जो कोटिंग करते हैं वो किसकी करते हैं? हम अंदर एक ऐसे मेटल को बिठाते हैं जो ज़्यादा रिएक्टिव हो, और बाहर एक ऐसे मेटल को बिठाते हैं जो कि लीस्ट रिएक्टिव हो. ठीक है, एंड दैट्स वाई जो ऑयलिंग करी जाती है और जो ग्रीसिंग करी जाती है किसी भी मेटल्स पे, वो इसलिए करी जाती है क्योंकि हमको सप्लाई कट ऑफ करना पड़ता है. just to cut off the supply of what? We have to supply the cut off of हाइड्रोजन आई मीन दिस H2 and O2, वाटर एंड ऑक्सीजन का सप्लाई को कट ऑफ करने के लिए ही हमें ये सारी चीज़ों की ज़रूरत पड़ती है, ठीक है। सो गैल्वेनाइजिंग, इलेक्ट्रोप्लेटिंग, एनोडाइजिंग एल्यूमिनियम या अलॉइंग, ये जो सारे के सारे टाइप्स हैं ये इसी के टाइप्स हैं हमारे पास में जो हम अभी यहाँ पर करते हैं। दैट इज़ वन ऑफ द थिंग ओवर हियर, ओके। कमिंग टू द नेक्स्ट पॉइंट विच इज़ अलॉय। Guys, anyone know about the alloys, that what is alloy?
Sir, the mixture of metals and non-metals is known as alloys.
Yeah. So the homogeneous mixture of two or more metals, or it is not always a metal and a non-metal. ऐसा भी हो सकता है कि we are having a metal plus metal, or we are having a metal plus non-metal. So that is known as the alloy over here. Okay, this is one of the thing which we can see. Alloy is nothing but what? The mixture of a metal and non-metal, and metal and a metal over here. So similarly you can see one thing. अगर आपने गोल्ड के बारे में देखा है, ठीक है ना, इफ़ यू हैव अगर आपने कभी शॉपिंग करी है या अगर आप अपने कभी पेरेंट्स के साथ गए हो, ठीक है ना, सो यू कैन सी देर इज़ अ 24 कैरेट गोल्ड एंड 22 कैरेट गोल्ड एंड 18 कैरेट गोल्ड. What do you mean by this carat? Can anyone explain me?
Sir, carat is the amount of gold in it.
Yes. इसका क्या मतलब हुआ? It is the purest form of gold. It is the purest form of gold. ठीक है ना? इसका क्या मतलब हुआ? जैसे फॉर एग्जांपल मुझे गोल्ड के साथ थोड़ी इम्प्योरिटी मिलानी है. क्यों क्यों कर रहा हूँ मैं ऐसा? इम्प्योरिटी क्यों मिला रहा हूँ मैं वहाँ पे? बिकॉज इन जनरल गोल्ड इज़ वेरी सॉफ्ट. गोल्ड हो गया, सिल्वर हो गया, ठीक है ना, आयरन जैसे हार्ड नहीं होता है. ये थोड़ा सा हार्ड ऑर्नामेंट्स बनाने के लिए हमें इम्प्योरिटी मिलानी पड़ती है. तो मैं क्या करूँगा, 22 जो पार्ट्स है वो गोल्ड के ले लूँगा, और जो 2 पार्ट्स है वो किसके ले लूँगा? कॉपर के ले लूँगा, ठीक है. इससे मिलके मेरा क्या बनेगा? ऑर्नामेंट बनेगा. और कॉपर के साथ में जब मैं गोल्ड को मिलाऊंगा, ठीक है ना, मुझे एक अच्छा ऑर्नामेंट मिलेगा. लेकिन इसमें प्योरिटी कम हो गई, क्योंकि यहाँ पे गोल्ड की कंसंट्रेशन देखो 24 कैरेट है, यहाँ पे गोल्ड की कंसंट्रेशन देखो कितनी है, 22 कैरेट्स है. और इसी तरह से यहाँ पर मैं 18 पार्ट्स किसके ले लूँगा? गोल्ड के ले लूँगा. सिमिलरली 4 पार्ट्स किसके ले लूँगा? 4 पार्ट्स कॉपर के ले लूँगा. गेटिंग द पॉइंट गाइज? तो प्राइजिंग सबसे ज़्यादा इसकी होगी, देन इसकी होगी, देन इसकी होगी, ठीक है. लेकिन गोल्ड सब में मिला हुआ है. गेटिंग द पॉइंट? दिस इज़ वन ऑफ द थिंग विच यू कैन सी. ओके गाइज. अच्छा, अलॉयज़ क्या होती हैं, कैसे बनती हैं, ठीक है ना, हमारे पास कौन कौन से अलॉयज़ अभी तक हमने बना चुके हैं, ये सारी चीज़ें अब हम धीरे धीरे करके इसमें देखेंगे. एंड यहाँ पर हमारा जो चैप्टर है वो ख़त्म होता है ऑन दी अलॉयज़. द ओनली पार्ट विच इज़ लेफ्ट विथ इज़ दी अलॉयज़ पार्ट, जो एक थ्योरेटिकल पार्ट है कि कौन कौन से अलॉयज़ हैं. ऐसा नहीं हो सकता कि आप आयरन को गोल्ड के साथ मिला दोगे और आप मेटल बना दोगे. नो, आयरन गोल्ड के साथ कभी मिक्स नहीं होगा. तो साइंटिस्ट ने ऑलरेडी these type of experiment scientists already did that iron do not show any properties with gold over here. So they never mix the iron with the gold over there. But gold and copper show a very high reactivity with each other, or you can say a bonding. Gold bonding is very high with the copper, so that's why you can see these type of things over there. Okay. Okay, fine guys. So with this note, this chapter is over now. Okay, now please have a practice of this thing. Okay, I will dispatch the questionnaires from my side. The chapter is over now. Whoever are left with the questionnaires, so just please practice this question, guys. Okay, I will dispatch the recording and all the things on your I mean YouTube channel and on the Telegram as well. So now whomsoever left with the um, this part, what we can say, mock test, just please go with that.
Yes, sir.
Okay, thank you. Bye bye, all of you. Thank you for joining the lecture.
Thank you, sir. Bye, sir.
Thank you. Bye bye. Bye bye, all of you.